Hello everyone, my name is Manish Mishra and I am an BTech computer engineering student specializing in AI and data engineering. So for the topic of today's video is stacks. In computer science, what is a stack? So a stack is an abstract data type that serve as a collection of element with there are two functions mainly push and pop. We will understand that in the later part of the video. So moving forward to our PPT, let's now understand what is stack first. Hmm. So moving forward to our PPT, stack. A stack is a pile of stuff. It is a structure that conforms to the principle of last in and first out, that is LIFO. So let's understand what is LIFO. Suppose you visit a marriage function, and of course you guys have already seen a pile of plates stacked up in the marriage function. So what do we see? That the first plate which was placed in the stack is at the bottom, whereas the top plate that was stacked later on at the last part is at the top. This is what LI stands for. Last in means the last plate will be at the first, and during when we take out the plate, the last plate would be taken out first. So this stands for first out. So this is what is the concept of LIFO. So the last item to join the stack, the last item to join the stack will be taken out first and will be served. So now moving forward, let's now understand what is push in a stack. For example, we have already given an example of a stack which consists of the first entry, which was 31, moving forward to 41, 59, 26, 53, 59, and later on at the last entry is 67. Now, as we can see, the stack already has uh, 1, 2, 3, 4, 5, 6, 6 entries, and we are now pushing in another entry which is 67 into the stack. So here push function will be used to push in the another data. Moving forward, now let's understand pop. In the last page, we have already seen that the 67 was pushed already into the stacks. So now we are removing that 67. As we know that it is a LIFO concept, means the last entry will be removed first. So 67 is being removed first. This is what pop function is. Now let's move forward and see. Now let's understand the concept. Now let's understand the concept. So stack, stack. For example, let's take a data. Mm, let's take a data, and it has four indexes named as 0, 1, 2, 3. All right. A data is pushed in to the stack. Suppose the data named is 0. Excuse me once. So the data named is 0. So what happens basically here, that the data that is 0 is pushed into the stack first, going into next iteration where another data named 1 is pushed into this a stack. A stack. So let's get the example where the data 1 is pushed into the stack 4. So what happens here, the index which earlier 0 had, that was 3, is now shifted to 2, and whereas the one which is now pushed into the stack is at index number 3. Similarly, in similar way, when another data named, for example, 2 is pushed into the stack, which is now, so what happens, 3, 2, 1, I've written index. Now when 2 is pushed into the stack, the last data which was at 3 index moves to 2, and the data at 2 index moves to 1. In similar way, when at last when 3 is pushed into the stack, 3, 2, 1, 0, the the stack is full now, means the whole stack is full with 3 2 1. And similarly the indexes, the index, there's an index shift in each case, each push case. Now let's understand another concept that is that that we will talk about the in the video. That name is overflow. What is overflow? All right, as in earlier example we have already seen, there was a there was a there was a stack name 3210. So when in this case, when the stack is full, then when we push another data entry, that for example is 4, then there is no space left in the stack to adjust number 4 data. Therefore what happens here, the compiler will throw a error named overflow. This condition is known as overflow when the data, when there is no space into the stack so that another element can be pushed in. Similarly, in similar way, we have another concept as underflow. Before underflow, let's understand what is pop. As I've discussed, let's take that same example of 3 2 1 0. Let's take this. When a function is popped, then the last and the data at zero index, which is this. One second. The data at zero index, which is this, is popped out from the stack. And here the two, here the 2 is now, shifted to 3, and 1 is now shifted, here 2 is now shifted to 0 index, 1 is now shifted to 1 index, and 0 is shifted to 2 index. So this is after 3 is popped out. So therefore after 3 is popped out, this goes as 1, this goes to the 2 space is taken by 1, and the 1 space is taken by 0, and the 0 space remains. Similarly, when again pop function is used, the data 2 is again removed and 1 remains and 0 remains. At last, when there is no data left in the stack, what happens when we again use pop function, the compiler will return an error named underflow, which means when the whole stack doesn't have another data and doesn't have other data, so doesn't have any other data to be popped out, this condition is known as underflow. Now we have understood what is underflow, what is overflow, what is pop, what is push. So now so I will be now designing a basic order tracking system, which is completely inspired from Blinkit, Blinkit, which is completely inspired from Blinkit. So now moving to my coding screen, let's see what is Blinkit. Hmm, Wait a second, guys. I will be just changing it to So I'm back to my coding screen. So make let's make the order tracking system of Blinkit. So let's now make first we will make a class. See, one second. First we have to make a class. So let's understand before we start. Let's understand what is class. So class is an pile of or pile of functions which are hidden into it. This concept of hiding functions or problems are known as abstraction, and the class supports abstraction and encapsulation also. So now let's move forward and make a class named order tracker. Order tracker. So order tracker class is now named. Yeah, that camera is good. So now let's move to order tracker, and we will make a constructor here. Okay, constructor type. First, first we have to make a list name. We are going to make a list name order updates where the whole data will be stored. This is stack data where the stack data will be stored. So moving forward, later we will later make the other things. Before that, let's make what we are going to display to the user that when he pushes the data and pops out the data. So for example, here the order the order will be pushed into the tracking system, and it could be it could be popped out. The order can be popped out. The order can be deleted, and dot and the order can be viewed altogether with also entry of new data. This concept will be on LIFO, and let's make our function name display. The user will get the option uh, to give the entry for its menu driven program. So we have created a function named delivery menu, and now let's print. This is an now let's print order tracking system. Order tracking system menu or Blinkit. All right. Okay. So now let's print enter order first. When the user gives first ones, that would be adding or add order. That means pushing order add order update order update, or you can also write it as add new order. Now print one more. We are now going to display, which means view order updates, because it would be more than one. Now the third one will be print three dot view order delete order updates order updates delete order, sorry, order update. And the fourth option which we are going to give to the user would be creating all the order at once. Delete all. And the last would be exit. Now there would be one more, which is a peak function in peak function, that is recent update. Okay, the top. Before we start, let's understand what is peak. So as I told you already, the concept of LIFO, in the stack, the top data, that will be the top data. When we use peak function, when we use peak function, the stack will return the top value in the stack which was entered last. This is what do you mean by peak. So now let's print the last. That would be number 6. All right. So now we have already made a class or a tracker. So before making the functions for add, view, delete, we are going to first make choices choices using by doing menu driven. For example, we are going to take order first. We are going to take it. We are going to create an object. Object tracker. Object tracker. Or order tracker. This is an object created for class order. For the class order tracker. The class order tracker. All right. Now, let's make a menu driven program. So while it's true, now display menu. This will call function menu. The function display menu. Here we have taken while is true because when the user wants to exit the menu driven, he can just return he can just put on 6 put the value as 6, and when he gives the value of 6 we will be returning false, which means the while will stop. So just in similar way we are going to now put a variable name to C, or you can also put choice, and we will just ask the user to enter his or her enter your choice 1 to 6, which is here. Here is 1 to 6. So here the user enters its choice from 1 to 6. Now move on. Now let's move forward and see. Yeah, it's correct. Now move forward and let's make for c if c equals to 1. When the value entered is 1, what will happen? Uh, it it will just it will just return. It will just ask user to input input uh, input the order. Okay, enter the order update. So what we will do, we are going to create a function above name as. We are going to just create a function named as def. For example, let's take as we are pushing update, pushing uh, putting update order update into it. So we are just going to create function named def push update, and we are just going to take data update from the user. Alright, so what we are going to do, we are going to just append or insert update, append or insert updates. Excuse me, sorry, updates. This function update this function. We are just going to add. We are just going to insert or push into the list order. Now, for example, this was our update. Now first we have to order. Sorry, mistake. It would be 0 comma 0 comma update. Here this data is taken into the main. Now let's make another function. Before we for example, we make another before let's make another for delete. No, we will make it afterwards after completing this whole thing. So we have already entered our choice. Now let's make another function, another choice. No, another choice named as, I guess, c equals to 2. So what happens here? For example, user wants to not view order. So user wants to see the order updates. So let's now just get updates equals to update equals to order tracker object dot get update underscore update. It updates. So what we will do, we are going to just make a new function named as order, sorry, get update, right? Get underscore updates. Get updates. So what do we do here is we are just going to return. We are just going to return. We are just going to return the above the list present into the constructor, that is self dot order underscore updates. So it will just return this update. Alright, so we are just we will just return self dot updates. Now before let's make another. See, okay. In the early part, let's make that the order was updated successfully. We are just going to just print before. Oh, sorry. In the first choice, we didn't call a function on it, so it won't return anything. So before we move forward, we are going to just call that function. For example, the function was order. The object was order tracker. Now we will call the push update value and send it to the EP. So and then print order updated successfully. So here in the second part of the, we will see that and for the choice two, we just make a new function named as get update from user, and it will just return this list to the updates. So what we do here is we are just going to, for I in updates, we are just going to get all the data present in the stack. So it will just print. It will just print order. Sorry, my mind. And if there is no value, If there is no value, it will just print no update. Print no update. Print no update. So now let's see next what we have to do. Okay, no update. No update. No update available. So now let's go to the third. That is elif c equals to 3. That was deleting. It would update. We are just going to ask user to enter. We are just going to ask user to enter. We are just going to ask user that. Wait a second. Yeah, it's good. Okay. So as the user selects the option 3, which means we are going to pop. So before we make this, we are just going to make another function named. For example, we are another function name. What is that function name? Pop function. Yeah, right. Okay. So just make pop, or let's make pop updates. Here I just going to make pop, and here that's data. Okay. So here the data, what we will do, we will just return. We will just write here. And first we will check if the list, or if the stack is not, empty, it will just return no previous no state, no delete. Thus it will return nothing. It will return none. But if we if we have data, then it will print first that the order which will be deleted. So let's now print first self dot order underscore update, which will be at 0 index, will be popped out from the function. So let's understand. Now let's make write update pop out. We will make a space here. Popped out. This popped out. Before we move forward, first let's update. Let's pop out the entry. So this would be order underscore age dot pop 0 index. Now let's go take this was for 3. Alright, now let's make first we have to make the choice. The choice of neutral event. So when the user selects 3, we are just going to make deleted date. Now we are just going to call the object order tracker, and, delete, and also the function delete pop in the function pop. So this was about our third part. Now moving for the fourth, which is delete all. We are just going to call. We are just going to print deleting. We are just going to print deleting all. Deleting all. Then we will call here and we'll call here the we'll just call here the object tracker and make a new function named del del yes, yes, that sounds good. So moving forward, now let's make that function named del all. So what it will do, it will just pop out each and every value in the it will just pop out each and every value into the uh, it will into the what is this into the list name order update or the stack name order update. So now moving forward, now let's make wait a second that earlier we have not included self in each function, so there was an error coming out. So here we will also include self. So now let's make for deleting all the data entry into the stack. So what we will do, we are going to just going to make a concept that we will just run a loop and just pop out each and every element at zero index. So we'll try to learn of order self dot order updates. Let's configure it index. So what I will do, we'll just do order update order underscore updates dot pop. We will also add self here because otherwise it will return error. So dot pop zero index. So what it will do, it will just pop out each and every thing present into the order updates. So now let's move forward and make so now let's move forward and make another function for our size that recent update view where the order will be picked. C equals to and fifth. No, fifth. It will just print. It will just print that it will just call function peek into the it will just call the function peek and give output to the compiler to the user. So now let's make another function named peek. Before let's latest update latest update just call it what we make is going to make def peek self named self. We are just going to check first we are just going to check whether the order tracker is true. So when it is true, it will we will just return order update at zero index to be so that it could be picked. Else we will just return that the list is empty. The list is empty. And as per the users sixth command, this is what we are going to do till if you know what was six, six was exit. For making exit, we can do two things. I would break or return false. So we are just going to break. We'll just print for our message. Thanks for using Blinkit order tracking or the order tracking system. Good. Okay. Have a nice day. Have a nice day. So what we will do here, we will just exit. That will be break. But before you go, suppose user gives a value named else. So this would be an error. So we are just going to print invalid invalid choice event so that the user can't give any invalid choice. The user knows. So now let's run the program and see. So let's now have one. So back to the business. Now we are just compiling our code, and there was few updates here that this will be updates here, and here it will be start from 0, and we are just calling the function pop for I times until until the length completes. So it will just call function pop I times, which means the length until the length of the updates. Now let's move forward and see. So first we are going to enter our choice 1, and suppose the order name is, for example, we have the order for the menu or tracking system, such as that's my rice. And a customer has ordered rice for his basket. So rice will be updated here. See, uh, enter, order updated successfully. Now again let's add grain. Now let's again add some more things such as oil. So we've taken 3 inputs. Now let's increase the stack, which is oil, grain, rice. Oil was entered at last, then grain, then rice. Now let's move forward, and now let's check. Now let's delete the oil part. So we have deleted oil. Here we can clearly see it is deleted. Oil update popped out successfully. Here the spelling is wrong. That would be P-O-P-P-E-D. Okay. So the oil is now popped out from the stack. Now move forward and make another. Again, let's add oil into it, and now let's delete all. Now let's delete all from the order. And but again, it is again showing error. I guess there would be a problem. Can only consider list, not into the list. That's correct. Now, let's think again. One rice, one oil, wheat, one oil, four. Yeah. So now it is good. It is now deleting oil and wheat, but it is not deleting the above one, the rice one, which was updated first. So I guess there is a problem in length. We have to add +1 here. Now it will work. Now let's uh, add again oil, again wheat, view it. We have wheat, oil, rice. Now let's pop out all. You can see all things has been popped out. All thing has been popped out successfully. No, it hasn't. It is not. It hasn't been popped out. Why it is getting from that one first side? Now let's remove while in this and make while order tracker. Now let's run again and let's see what is the problem. If a problem occurs again, let's delete this and run again. Add add the rice here, then add oil, then add wheat. Now let's delete. Now let's delete. Yes, not empty. Just now, I agree. It will empty. It would be greater than 0. Let's add rice here. Heat. Let's add oil and in it off. Let's, yeah, I know what is the problem here. What I was continuously making on a tracker. Is it what we have to do? We have to write or updates this variable problem syntax. It is completely a syntax logical error. Now let's update it until order update self dot order update self dot. I guess this was a mistake we were making from 100 part. Update it will be order updates. So again, let's try and see if it works. Oil, rice, wheat, and read. And yeah, as you can see, the wheat, rice, oil has been limited. So we already we knew what was our problem. Now it has been solved. And now let's add again. For example, we've added in rice. And now let's check for number 5, which will show what's the latest update that was right. This is absolutely correct. Now let's exit to the system, which we have to do by pressing syst, and it will just print thanks for using Blinkit order tracking system. Goodbye. Have a nice day. So this was all about video. Before one, let's make an invalid input into it. For example, and it will just return invalid file given, and you just given again chance to enter update. So this is how the whole stack works. That's all. Thank you everyone. Let's meet you in the next video.